Hey everyone, in this video we are going to talk about logarithms. So let us consider this expression 2 raised to 3 is equals to 8. Now if I have such an expression, I can say that logarithm of 8 to the base 2 is equal to 3. Well, what is logarithms? Well, from what I've written on the screen, it seems that the log of 8 to the base 2 means that the third power of 2 is going to give me 8. In other words, I can write if I have log of a to the base b. Well, I can say that this is going to give me what power of b is equal to a. Right, so this question marks value is basically log of a to the base b. Right, basically the log of a value gives you the exponent. So let us solve this problem. What is the log of 81 to the base 9? Well, the log of any number gives you the exponent, right? What exponent? Well, this expression basically means that what raised to 9 is going to give me 81. Well, 9 square is 81. Hence, log of 81 to the base 9 is going to give me 2. So in these two terms, we have 9 as the base, right? And the log of that number, that in this case the number is 81, is the exponent of 9 that is going to give me this number 81. Is that correct? Alright, now you know that a logarithm has a base, right? In the previous problem we solved, log of 81 had a base 9, right? So if you have some log to the base 10, right? If the base of this logarithmic expression is 10, it means that this is a common logarithm, right? A common logarithm is specifically a logarithmic expression in which the base is 10, right? When the base is e, that is the Euler's constant, it is known as a natural logarithm. The value of this Euler's constant is approximately 2.71, right? So common logarithms and natural logarithms, many a times these logarithms have been calculated and put into log tables, right? There are log tables for majorly common logarithms of numbers. Now if you use a calculator, you may find two buttons related to logarithms. This log button is basically for calculating the common logarithm of any number, and this ln button is specifically used to calculate the log of, the natural log of any number. So if I have to calculate the common logarithm of 1000, it should give me 3, because the base of common logarithm is 10 and 10 raised to 3 is 1000, right? So it does give me 3. But if I calculate the natural log of 1000, it gives me something else. It gives me 6.90, because 2.71 raised to 6.90 gives me 1000, right? I hope you got the difference between these two types of logarithms. Of course, we can have logarithm with any base. Now, a logarithm of a number has two parts. One part is called a characteristic and the other is called as the mantissa. The characteristic is the number that is present before the decimal point, and the mantissa is the number that's after the decimal point. Now, there is a method of calculating the characteristic of a logarithm. The mantissa, you can get it from the log table, right? Now, there are two cases while you calculate the characteristic of a logarithm. The first case is the number is greater than 1, and the second case is that the number is less than 1. Now, which number am I talking about here? Well, this number of which you want to calculate the log of. Right? When the number is greater than 1, the characteristics is 1 less than the number of digits in that number, right? The number of digits in 1000 are 4, and hence its characteristics is 4 minus 1, and that's 3, right? When this number is less than 1, then it's a little bit different story. The characteristic is 1 more than the number of zeros after the decimal point, right? So if I have a number, like if I have to calculate the log to the base 10 or any base of 0.6173, well, the characteristic is going to be 1 bar, right? We put bar if the number is less than 1. Now why this 1? Because there are no zeros after the decimal point. So 0 is the number of zeros plus 1, hence this 1 point. The mantissa is going to come from the log table. If you have log to the base 10 of 0.061, then it is going to give you 2 bar. Why 2 bar? Because there is one consecutive 0 after the decimal point, right? Had there been 2 zeros, this would have been 3 bar, right? I hope you got the point.